So edits to make to the review sheet, or if you're just writing this down on a piece of paper, from old test questions. That's the best way to study, really. Some of your old test questions will appear on the exam exactly. Like the exact test question will be the question on the exam. Sometimes there's a slight modification to it, but the same idea is there. So looking at old tests is the best way to study. I don't give out copies of the old tests, so hopefully you held on to yours and can find those, and if not, check with a friend who wouldn't mind letting you make a copy of theirs. Some of this stuff we'll be going over the next couple days, so you can just take notes on that, but we're not going to hit every single topic over the course of the next couple days. There will be some things you need to review on your own by looking at old tests or notes. So the first one that it refers to is the Chapter 8 test, it says on the top of it. It's got some square roots on the top, and then it's got some triangles in the middle. I can hold up what that one looks like. Looks like this. Okay, so it's got some triangles in the middle and some square root stuff on the top. That one, the review sheet is correct about the numbers. On that one from the Chapter 8 test, we would want to be looking at numbers 4 through 7, 4, 5, 6, and 7 there. Then on the review sheet it talks about flatland. From flatland, you're going to look at the multiple choice test. That's what you're going to want to study there. I am not going to review flatland with you. You'll be responsible for reviewing that on your own. On the exam, I'm really trying to stick to the big ideas of flatland, not be nitpicky on details, but just stick to the big ideas there. Then it starts referring to trig, and here's where we're going to have some major changes. So you might just want to even scratch out what it refers to there in terms of test questions and put in this new information. The first one that we're going to look at the top says Chapter 8, Quiz 2. It has just a lot of right triangles on it, and at the bottom is a word problem. Okay, so Chapter 8, Quiz 2. This was our beginning of trig stuff. On that one, we're going to want to think about problems 1 through 3. The next one from trig says trig no calculator at the top of it. The first 3 questions asked you to draw angles, and then at the bottom it was converting stuff.
Is that like the sines?
Yep, trig is the sine, cosine, tangent stuff, yep. So the one that says trig no calculator on it, on that one, the questions to review are going to be 4 through 18. And then the last trig quiz to review says trig quiz calculator at the top. There are just 5 questions on the front, lots of blank space there to work the problems. So when it says trig calculator, on that one you're going to look at problems 1 through 5. Okay. So the trig on the review sheet refers to kind of the old way I used to test trig with just 2 of them this year and last year as well. Actually, it was split into 3 quizzes, so that doesn't quite line up with what the review sheet says. The next thing on the review sheet says constructions. So there will be constructions on the exam, which means that you will need a compass for your exam. The constructions are the basics. So that's parallels, perpendiculars, bisecting angle, bisecting a segment. So that's like the first quiz there. We're not going to review that part together, so that'll be something that you'll want to make sure to review on your own. The next thing on the review sheet on the back is circles. That test says Chapter 9 test on it, and there's lots of pictures of circles on it. And the numbers that are listed on the review sheet for that are correct. So the numbers from that one are 1 through 10, 11, 12, I don't know why I didn't say 1 through 12, 15, 16, 17, and 20 are the questions that are listed there on the review sheet for the circle task from Chapter 9, and that is correct. The next thing on the review sheet says area and volume test, and this needs to be edited. I used to do area and volume as one test. Now, this year I split it into two separate ones, so it wasn't as much material at once. So the problem numbers there are no longer applicable. So from the area test, which says Chapter 11 test area at the top of it, and the front was all the formulas and the back was the problems. From the Chapter 11 area test, we're going to want to look at numbers 1, 2, 4, and 6. And from the volume test, which was Chapter 12, once again, the front is all the formulas, and the back was where you would solve problems using those formulas, numbers 1, 2, and 7. So the problems listed on the review sheet don't apply because that applied to when it was all together in one test. It says on your review sheet that you may use a formula sheet for your area and volume test. For your area and volume part of the exam. I will give you a sheet that has all of the area and volume formulas that you will need on it. So on the actual test, when you took them, you needed to write in all the formulas. For the exam, I will give you a sheet that has all those formulas, so you don't need to worry about memorizing any of those formulas for the exam or re-memorizing them. You should have had them memorized already, but re-memorizing. Then on the review sheet, it says probability. That probability test that we just took, the problems listed there are accurate for that. So for the probability test, that's numbers 1 through 4, 6 to 10, and 11 to 13, basically the whole front page on that probability one. And then the last topic is transformations. We did not take a test on transformation, so you don't have a test to study from here, but you need to be able to do the basic transformation. So to translate or slide a figure, to rotate a figure, to reflect a figure, or to dilate a figure where we blow it up to a bigger or smaller size. So being able to do those basic transformations, but you don't have a test to go from for that. Questions so far? I decided last night to do something that I've never done before and allow a 3-inch by 5-inch note card for the exam. So I don't know why I decided this last night exactly. I'm still a little torn, but I decided it. So you may have a 3-inch by 5-inch note card, front and back. And when I allow note cards, I don't give restrictions on what you can put on there. So I'm not going to tell you can put this, you can't put this, you can put this. If I'm giving you a cheat sheet, I'm going to let you cheat in the way that you want to cheat. So you can put anything on there from writing out examples to writing out directions or formulas, whatever you want to put onto that note card, but it must fit onto a 3-inch by 5-inch front and back. You could, if you want to, type it up on a computer and put it in like size 2 font and bring a magnifying glass. I don't care, but it must fit onto a 3-inch by 5-inch note card. Okay? Questions? Start our review with Chapter 8. The first thing that we did in the semester and also the first thing that's on the review sheet there. We're going to start by looking at the Chapter 8 test. On the Chapter 8 test, it says that we're going to look at problems 4 through 7. Each of those has multiple parts to it. There was like A, B, C, C's, etc. So we're not going to do every single one from there, but we'll do each type of problem that shows up on that test. That could show up on the exam. And again, sometimes it's the exact same question. Sometimes it's the same type of question, but the numbers are changed. So for the first group of questions, question 4, you need to know some formulas that are actually in question 3. We use this picture to be able to solve for missing pieces in the triangles. And from this picture, we had 3 formulas. That C was the square root of AB, that D was the square root of A times A plus B, and that E was the square root of B times A plus B. Okay, so this picture and those formulas might be something you would want to put on a note card. Okay, I'm not going to tell you exactly what to put on there. You need to put on there whatever you think is going to be helpful to you, but I think that this might be helpful to many of you. So these formulas in that picture are how we're going to solve the problems in question number 4. So in question 4, we're given pictures that look like that one, but have some numbers in it. So the first one looks like this. And we want to solve for what x is. So lining it up with the model picture, we want to know C and we know A and B. So that means the first formula is going to be the most helpful to us. C, which is x, equals the square root of A times B, which are 2 and 8. 2 times 8 is 16, and the square root of 16 is 4. So 4 would be the answer to that question. Of the same type of problem, the next one I want to look at on the test was part C. It looks like this. So we still have the 2 and the 8, but we move the x to a different location now. So now if we line that up with the model picture, x is in the spot of E. So we're going to want to use the formula that has E in it. E is x equals the square root of B is 8 times A plus B is 2 plus 8. So x is equal to the square root of 8 times 10, which would be the square root of 80. Answers should be given as simplified square roots when possible, not decimals. We want to simplify this down, though. Instead of leaving it at 80, when we simplify square roots, we're thinking about a perfect square that divides into that number. So 80 is the same thing as 16 times 5. 16 times 5 is equal to 80, and 16 is a special number because the square root of 16 is 4. So we want to break down that square root. That is something that we learned in that same chapter, chapter 8. Problem number 1 kind of refers to how to do those. You're not going to be tested directly on that, but your answers should be simplified when it's possible to simplify them. Okay. We'll look at one more of this type. On the test, it is labeled as question D. So if we line up with the model here, we're given that 6, which is in the E spot, so I should use the formula that uses E again. So E is 6 equals the square root of B is x times A plus B. What is A plus B? 9. A plus B is the whole bottom of the triangle. So I don't know what A is and I don't know what B is, but I know that together they make up the bottom of that triangle, which is 9. So that x is trapped underneath the square root. So to be able to solve for it, we need to help it escape from there. How do we get rid of that square root? Square both sides. So squaring undoes square roots. Those are opposite operations. So that gives 36 is x times 9. Divide both sides by 9. And we get 4 is x. Questions on that type of problem? Right. There are 3 more examples of that on the test, but I'm not going to do all of them for time, but that might be a good idea for you to go back and look at those as well. The next question on the test was question 5, and that refers to given 3 numbers, how we can tell what type of triangle it is. So a squared plus b squared equals c squared means that we have a right triangle. So if our three numbers follow this formula, that means we have a right triangle. If a squared plus b squared is smaller than c squared, or reading it backwards, c squared is too big. If the individual is too big, that means that we have an obtuse triangle. Or if a squared plus b squared is bigger than c squared, or saying it backwards, that the single side is smaller than the sum, we get acute. We always want to think about the comparison of how the single compares to the others. If the single one equals the sum, it's right. If the single one is bigger than the sum, it's obtuse. If the single is smaller than the others, then it is acute. So given three numbers, we want to be able to tell what type it is. So the first one of these on the test is 5, 7, and 8. The biggest number is always C. Okay? So it doesn't matter what order they come in. They don't necessarily come in order A, B, C. The biggest one is C. A and B don't so much matter. So we're going to do 5 squared plus 7 squared and compare that to 8 squared. So that's 25 plus 49. If I add that up, I get 74. 8 squared alone is 64, which is smaller than 74. If the single is smaller than the sum, the triangle is acute. The order of the numbers does not matter. The biggest number has to be C. So this one we're going to do 6 squared plus 8 squared and compare that to 12 squared. You always want to do the biggest one all by itself. So that gives 36 plus 64 is 100. And the other one by itself is 144, which is bigger. If the single is bigger than the sum, the triangle is obtuse. Okay. Questions on that type of problem? All right, the next type of problem, still from chapter 8, is our Pythagorean theorem for right triangles. So in a right triangle, a squared plus b squared should equal c squared. So the next type of problem, you are given a right triangle and two sides in that triangle and asked to find the other side. So we can apply our Pythagorean theorem. C is always the hypotenuse, because C is supposed to be the biggest, just like it was in the last problems, and the hypotenuse should always be the biggest side of the triangle. So x squared plus 4 squared equals 5 squared. X squared plus 16 is 25. Subtract out that 16 and we get 9. So x would be 3. 3, 4, 5 is actually kind of a special triangle that shows up a lot. If that's something that you happen to know or recognize, you don't have to show work. But if it's not something that you know or recognize, the Pythagorean theorem will always get you there in a right triangle. Let's do another Pythagorean theorem example. The hypotenuse always needs to be C. Yes? So in this one, I'm going to do 6 squared plus x squared equals 9 squared. The hypotenuse always needs to be alone because it should be the biggest. So that gives 36 plus x squared is 81. Subtract 36 from both sides. Gives 45. And we would want to take a square root. That is not a nice number. Square root of 45 is not a nice number, but exact answers should be given and simplified when possible, not decimals. So when we want to break up a square root, we want to think about a perfect square that divides into that number. So a perfect square that goes into 45 is 9. 9 times 5 is 45. square root of 9 is 3, and square root of 5 we have to leave because it's not a nice number. Questions? The last type of problem from the Chapter 8 test that we want to look at are special right triangles, which are 30, 60, 90 triangle and 45, 45, 90 triangle. In the 30, 60, 90 triangle, the pattern is 1 for the short side across from the 30, hypotenuse of 2, square root of 3 for the longer leg across from the 60. In the 45, 45, 90, the pattern is 1, 1 for the two legs that are the same since it's isosceles, and square root of 2 for the hypotenuse. And those are rules that are always true for those particular angles in a triangle. So the next group of problems on that Chapter 8 test gave you a triangle that fits one of these special patterns and asked us to come up with some sides. So this one has a 30-degree angle, so it fits the 30, 60, 90 pattern. We are given the 5, which is across from the 30, so that should be like the short side. So that should kind of match up with the 1. According to the pattern of the 30, 60, 90, the hypotenuse is twice as big, so 1 to 2 is twice as big, and the longer leg is the square root of 3 times as big. So in this one, our hypotenuse is twice as big, and the longer leg is the square root of 3 times as big. Okay, so we're taking the idea of our model or basic triangle up at the top and thinking of kind of blowing it up to 5 times as big. In a 45, 45, 90, the two legs should be the same. It's an isosceles triangle, so y should be 18, just like the other side is 18. The pattern for the 45, 45, 90 is 1, 1, and the hypotenuse is times the square root of 2. So in this problem, it's like we're taking it and blowing it up to be 18 times as big as the original. So that hypotenuse is going to be 18 times the square root of 2. Questions on 30, 60, 90 or 45, 45, 90 pattern? We're going to look at then is the one that says Chapter 8, Quiz 2 at the top. And this is where we began doing our trig stuff. Chapter 8, Quiz 2 is our first trig quiz. The big key on this one is that in a right triangle for trig, we can think about SOHCAHTOA. Each one of those letters means something. The big ones meaning our 3 trig functions of sine, cosine, and tangent. And the smaller ones meaning the sides of a triangle, opposite, adjacent, and hypotenuse. So by spelling out this word or this name, it gives us which trig functions use which sides of the triangle. So the first question on that quiz gave us a triangle with one angle in one side and asked us to find another one. Well, technically 2 angles, I guess, because we have the right angle. This is not one of those special ones. It's close to one of the special ones that we just looked at, but it's not a 30, it's a 32. So it's not quite perfect there to just be able to follow our pattern. So then we need to use trig on it. So what we do is focusing on the given angle, name the sides of the triangle according to the relationship with that angle. So what kind of a side is the 22? Adjacent, because it's right next to the 32. Adjacent means next to or touching. Technically, the 32 is also touching another side, but that side is our hypotenuse. The hypotenuse is always located across from the right angle. So when we say adjacent, we mean the not hypotenuse one. Okay? Hypotenuse across from right angle, adjacent's the one that's touching it. That's not the hypotenuse. Which would mean that x has to be the opposite. It's across from the triangle. So straight across from that 32, or opposite of that 32 is the x. So in this problem, we're looking at adjacent and opposite. So if we look at SOHCAHTOA, the trig that deals with adjacent and opposite is tangent. So we're going to use a tangent here. Tangent of 32, the angle always goes inside of the trig name. So we do the trig name, whether it's sine, cosine, or tangent, and then the angle equals, and tangent is opposite, which is x, over adjacent, which is 22. And we want to solve for that x, so I can multiply both sides by 22 and type that guy into the calculator. 22 tangent 32, and I just type that right in the calculator. It will give you a decimal, but that's okay here because it's not one of our special patterns. If it's one of our special patterns, we want some exact answers, but here it's not a special pattern. We'll look at another one. So in this one, if we focus on that 40 that we're given, what kind of a side is the 12? The hypotenuse, it's across from the right angle. And what kind of a side is the x? The adjacent. So we don't really care about the other side because they didn't put a number there and it didn't put a letter there that we're supposed to find it. So all we really care about is those two sides, adjacent and hypotenuse. So when we look at SOHCAHTOA, if we're working with adjacent and hypotenuse, we're going to be working with cosine. So we're going to do cosine of the angle equals adjacent over hypotenuse. So cosine of 40 is equal to x over 12. To get that x alone, we'll multiply both sides by 12, and we type that guy into the calculator. When we do that, we get about 9.2.
What did that stand for?
Sine, cosine, and tangent, and then the opposites, adjacents, and hypotenuse. So it tells us that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So it's giving us our three trig functions and which sides of the triangles they use. The last thing we're going to talk about today is the trig quiz calculator one. We'll go back to the non-calculator one tomorrow when we have a little bit more time. So today we're going to look at the trig quiz where we used our calculator. So for the exam, things that you should bring with you, a compass, okay, because there are constructions. So a compass, your note card, a calculator, and a pencil. You don't really need anything else. But you do need a compass for the constructions. You'll definitely need a calculator and a pencil, and you're going to want your note card. So on the trig quiz for the calculator, this is where we use our law of sines and law of cosines to solve for sides of triangles. The law of sines and law of cosines will be printed on the exam. So you don't need to put those onto your note card. You can, but they're already going to be on the exam, so you don't really need to worry about those. Okay, so those two formulas are printed on the quiz as well, and they will be printed on the exam.
On the review sheet for the circles, it says no definitions. We have from 9.1, 9.3, and 9.5. But do we need no definitions of like theorems or anything?
No, but we'll talk about circles tomorrow or Monday. So on this calculator trig quiz, we'll look at a couple of examples. The first one we'll look at is problem number 2, which gave us a picture like this. When we did these lessons, we learned to make lists of what we know and what we need to know. And that we're going to solve for everything that we don't know. So we know angle A is 15, we know angle B is 20, and we know side C is 10. Remember, in triangle, sides are named across from angles. So that 10's across from the C means that that 10 is side C. So then we need to find the 3 missing pieces of information. The easiest thing to find first is the other angle. What do we know about 3 angles of a triangle? They add up to 180. So I can take what I have so far, subtract it from 180, and that tells me how much I have left for that other angle. From there, we will use our law of sines or law of cosines to solve the problem. We can use our law of sines when we know both parts of one letter, which we do here. We know both parts of letter C. The law of sines, again, will be printed on the exam, so you don't need to worry about putting this on a note card or memorizing it. But it's that we do sine of an angle over its matching side. So we can do this when we know an angle and its matching side. So we're going to set up, using the pair that we know both parts of with letter C, sine of 145 over 10 equals, and it doesn't matter which thing we go for first here, so I'll just go alphabetically and say sine of 15 over A. When we have a fraction equals a fraction, we can solve by cross multiplying. So I get A times sine 145 equals 10 times sine 15. And to get A alone, we'll divide by that sine 145. Then we're going to type this whole guy into the calculator. When you press your sine button or cosine or tangent or any of your trig buttons on your calculator, it will automatically open up a set of parentheses. You need to make sure to close that up after you're done typing in your angle. Don't just leave it hanging open for the rest of the problem, or it will create a wrong answer. So make sure after you type in an angle that you close up the parentheses that your calculator opened. When we type that all into the calculator, it gives us about 4.5. Should be our answer for side A then. We still have to find side B, so we're going to repeat the process. I like to go back to the first set using the same set of side and angle that I used. Just in case that 4.5 is wrong, then my next answer could still be right. It's not the problem from here on out, but this time using sine of 20 over B to find the last piece of information. Cross multiply. And divide out. Once again, when you type this guy in the calculator, make sure that you close the parentheses that the calculator automatically opens. And this gives us an answer of real close to 6. All right. Questions on that one? Okay, so then the next type of problem is what we do when we don't have both parts of one letter. So for that, I'm going to look at question 3 on the test, which when I arranged that information into a chart, it didn't give us a picture, it just gave us values. So we can just plug them into our chart. I do not know both parts of one letter, and I don't know 2 angles, so I can't subtract from 180. So this is where our law of cosines becomes necessary. Like I said, the law of cosines will be printed on the exam, so you don't need to worry about memorizing it. The law of cosines says c squared equals a squared plus b squared, kind of like the Pythagorean theorem, then minus 2ab cosine of c. Remember, the letters can be shuffled, so that I wrote it with c alone, but you could write it with a alone if you just swap out all the c's for a's. Okay. So we're going to plug in what we know here. I do not know little c. I know little a is 8, little b is 6, little a is 8, little b is 6, cosine of big C is 60. So everything that remains on that side of the equation is a button that I could press on the calculator. There's no variables over there. The only letter that was left for a variable is over on the other side all by itself. So I can plug in everything on that side of the calculator and it gives me 52. About. Maybe exactly. That is equal to c squared. That is not equal to c, so we need to take a square root. Square root of 52 is not a nice, neat number. I'm not going to have you simplify your roots here when we're doing our law of sines and cosines. We didn't simplify roots for that quiz either. If you're ever unsure while you're taking the exam whether decimals are okay or not, you can always feel free to ask, and I will tell you whether or not you can use a decimal. But here we can, and that's about 7.2. Now we know both parts of one letter, so now we can go back to our law of sines. Setting up sine of angle over matching side equals. When you are solving for angles, you should always go for the smallest angle first. The smallest remaining angle needs to be solved for first. And that's going to be angle B. Remember, your smallest side matches your smallest angle. So the smallest side was B. That means the smallest angle is B as well. So to solve this out, I'm going to multiply by 6 on both sides to cancel out that denominator and type this guy into the calculator. When I type that into the calculator, it is going to give me a big decimal that is not yet my final answer. It gives me 0.721 blah blah blah, but that is equal to the sine of B. So to undo that sign on the calculator, we need to do inverse sine or second sine of that decimal, and that gives us our angle. The way we undo a sine or a cosine or a tangent is with the inverse, which on the calculator is the second button. And that gives us our angle, which is 46. Yes?
For the sine 60 over 7, do you type all that in first and then times it by 6?
I just type it just in like that. So I do 6 sine 60 divided 7.2. Just type it all in at once. But you could do the fraction and then multiply by 6. That'd be the same thing. I just type it all in one piece. Always find your third angle by subtracting from 180. You could do some trig on it, but it stands a chance to get a wrong answer then. So it is easiest and safest to just subtract what you have from 180, which leaves 74 left over for that final angle. Okay? Questions? Tomorrow, we will talk about the other trig quiz, which was the no calculator one, and probably start talking about circles. The big ideas that I wanted to review with you were Chapter 8, trig, and circles. The rest of the review, you'll be pretty much on your own for. Please do ask questions if you have it, but I don't plan on doing directed review on the other topics. But these 3 big topics of Chapter 8, trig, and circles, I'm going to direct the review.